muscle cell, but I'm leading you into chapter 7.
Okay.
So neuron.
Okay.
And all 3
I
muscles.
just want to know what to like focus.
Okay,
My
so focus
brain
on neurons.
Okay.
And then I will remind you when we get to muscles. Now remember the resting membrane potential. Okay. Now we have some slides that talk about that too. Here we go with our -70. Fixed anion means it can't leave the cell. It's fixed in place. That's DNA and the big proteins. There's what I've just drawn. I just like to draw it while I describe it. I don't know if that helps students. Do you find that help? More than just looking at those?
Yeah.
Okay. Again, from your book showing the sodium potassium pump is the one that's affecting it all the time. Now, it's very sensitive to potassium levels. So let's look at what would happen if we had a lot of potassium out here. Potassium, and that would be a serum potassium greater than 5.5, maybe equivalence 3. What would happen?
Heart stops functioning properly.
You have to explain why. That's correct. But why?
Too much potassium.
Keep going. So what happens to the cell? We're at the cellular level. What?
Does it burst?
No.
The charge is off.
Charge is off. How is the charge going to be off? It becomes more powerful. So instead of being at -70, maybe instead it's going to be -50 or -30. It's going to be higher. Higher means it will fire easier. We haven't talked about threshold yet, but it means that it's more likely to fire quicker, which gives us arrhythmias. Now, what I saw as a coronary care nurse was a high potassium in a patient had a heart that wasn't as contracting as well, was what I saw, was their blood pressure was lower, their heart was almost kind of floppy. All right, now let's look at the other circumstance. Let's say that their serum potassium is low. So let's see, that's potassiums. Okay. Now what happens? What?
Be more negative.
Be more negative. Good job. These are all going to want to leave. So that makes this more negative. More negative means even harder to fire. It's going to take more effort to get a neuron to fire or to get a heart to fire, pacemaker to fire. And so now what I saw, again, in coronary care, the cells started getting uncoordinated because the pacemaker was no longer pacing the heart like it ought to, because the membrane potential was too low, so it wouldn't fire like it ought to. Well, if there's nobody in charge, you know, the little cells start running around doing their own thing. They know that somebody's supposed to be beating, they're not getting instructions, so everybody beats, but they're not talking to each other, so everybody beats on their own. And so ventricular fibrillation, where every single cell is doing its own thing, can happen because the potassium is too low. And that's why potassium is one of the first things checked. When there's a code, something's happened to the heart, we do a stat potassium level to find out, is it too high or is it too low? Questions about that so far? slow and understand what's going on, because this is where all the drugs are gonna work. All the drugs are going to affect these ions. That just makes this sucky sound.
How do they treat if the accident's too high, how do they encounter that?
By giving, oddly enough, insulin and glucose, which pushes more potassium inside the cell. That's our emergency response. Dialysis will be the, after we get the heart started again,
Yeah.
response.